The fundamental theorem of calculus allows us to know how to take derivatives of functions where I'm integrating up to a variable. And in particular, it tells us that this function that's defined by the integral of some whatever function is an antiderivative of the function inside. So in particular, I want to introduce a function here that my function a of x will be this integral, and in our example I'm starting at 3, so I'll use that value. The integral from 3 to x of my function sine of t squared. And the fundamental theorem of calculus tells us that the derivative of this function is the integrand function. So here it's sine of the input squared, and so it's the sine of x squared. So that's what the fundamental theorem of calculus says. And it allows us to answer our first question. If I take a derivative of this integral, I'm taking a derivative of that accumulation function of x. Because that's exactly what a of x does. It does the integral from 3 to x. And so its derivative is the sine of x squared. So that's by the fundamental theorem of calculus. Our second problem, notice it has, instead of x, it has e to the 2x. And what that means is that I'm not taking a derivative of a anymore. I'm taking a derivative of a evaluated at the input e to the 2x. So instead of just using the fundamental theorem of calculus, this time I have to use the chain rule. I have a composition, I'll need to use the chain rule. The chain rule says the derivative of a composition is the outside function leaving the inside alone times the derivative of that inside formula. Okay, well, what is the a prime function? The a prime function is the sine of the input squared, e to the 2x squared. And the derivative of the input is 2e to the 2x. So our final formula for the derivative is 2e to the 2x times the sine e to the 2x squared is e to the 4x. And this is the derivative of our second function. Now for our third function, notice that this time I have formulas in the top and the bottom. It's no longer 3. So, by the fundamental theorem of calculus, the other part of the fundamental theorem of calculus, this definite integral can be thought of as a evaluated at x cubed minus a evaluated at square root of x. And I still need to take a derivative of this. Okay, so what have I done? I've taken my definite integral and I've expressed it in terms of the antiderivative function that we found using an integral. So we know how to take a derivative. The derivative of a is a prime, same input, but we need to multiply by the derivative of the input. So we multiply by 3x squared. And then we'll subtract a prime. This time our input is the square root of x, or x to the 1/2, and I multiply by the derivative 1/2 x to the minus 1/2. And I now use the formula for my a prime function it's the sine of the input squared. Sine of x cubed squared is x to the 6th times 3x squared. And then we'll subtract a prime, that's the sine of the input squared, square root of x squared, times the derivative of the square root. So that's 1 over 2 square root of x. And normally we want to simplify how that looks, so we would put the 3x squared in front. 3x squared sine of x to the 6th. And then minus 1 over 2 square root of x sine of x. And this is the derivative of the third integral. This is how we use the fundamental theorem of calculus to create a function that is an antiderivative, and once I know the derivative of a, I use it based on our variable limits of integration.